On a bright and sunny day in Maui, Hawaii, a group of teenage friends decided to skip school and catch some waves, as they often did. But as they paddled out to the lineup, they sensed that something different was in the air. Despite their unease, they kept on and took a moment to appreciate the scenery around them. Suddenly, one of the guys was pulled off his board and into the ocean by a massive tiger shark, its teeth sinking deep into his flesh. The friends quickly jumped into action, their adrenaline pumping as they fought to save him. They managed to pry the shark off and loaded their injured friend onto their surfboards. They paddled frantically to the shore, blood gushing from the surfer's wound and time running out. Once they reached the beach, they rushed their friend to the hospital for emergency medical treatment, their hearts heavy with fear and shock.
Doctors took him to the emergency room when he arrived at the hospital. After examining his injuries, medical professionals moved quickly to stabilize the situation. It was found that his leg needed to be amputated because of the serious damage it has sustained. The doctors quickly prepared for surgery to remove the injured leg. The procedure went very well. Medical professionals attempted to keep him as comfortable as they could by reducing his discomfort, checking his wound for infection, and cleaning it. In order to help him deal with the trauma of the shark attack and loss of his limb, they also gave him counseling. Then they get in touch with the prosthetic business to order a replacement limb.
Additionally, the company must hire mechanical, biomedical, and materials engineers to develop the prosthesis. These engineers must collaborate to guarantee that the prosthesis meets functional criteria, is long-lasting, and is safe for the patient.
The mechanical engineer's role in the whole process will be to conduct a statics and dynamics analysis of the mechanism in order to ensure that the leg prosthesis will function properly for the patient. Their responsibilities also include the coordination of its development process. In other words, they will revise the device's mobility and make sure it can support the patient's weight. In a more technical perspective, this process will be translated by designing and developing mechanical components, completing design for manufacturing and design for assembly processes for those components, analyze and test the created systems as well as improving them. Those will involve computer-assisted design as well as applied theory of statical and dynamical physics. Mechanical engineers will have to collaborate closely with other involved engineers as well as physiotherapists, doctors, and patients in order to understand what kind of movements the patient wants or needs to be able to complete. This information will be vital in order to develop a suitable prosthesis for the patient.
Biomedical engineers work within the medical field to better the engineering properties of biological systems. This type of engineering has a goal of making technological advancements in the medicine field. Bioengineers work closely with doctors to ensure the success of their patients. Seeing as the patient requires a prosthetic limb, a biomedical engineer is needed. A prosthetics engineer must come up with new designs for prosthetics, as well as think of ways to improve older models. They do so with sketches and different software to help map out the limb. Once the designs are made, the engineers will firstly consult with manufacturers and additionally check in with the doctors to make sure the patient's needs are being met. Once a suitable model is decided for the patient, the biomedical engineer regularly checks in on the patient. By receiving feedback throughout the patient's rehabilitation, the prosthetics can be reworked and redesigned prior to their next launch.
Material engineers play a crucial role in prosthetic production. They are responsible for selecting, designing, and testing materials which must be strong, durable, lightweight, waterproof, and able to withstand the wear and tear of daily use. To start, the patient needs and requirements are evaluated since no two prosthetics are the same, as the users vary in size, weight, lifestyle, and amputation. Thus, there is not one material or design that will fit all needs. The materials and composites can vary depending on the specific application and the needs of the patient. Some of the most used ones include polyethylene, titanium, carbon fiber, and silicone. Once a material is selected, they will work closely with manufacturers to make sure that the specifications and that the final product meet all safety standards. Overall, material engineers play a critical role in ensuring that their prosthetics devices are safe, effective, and provide patients with the mobility and functionality they need to live their lives to the fullest.
When the young man receives his durable leg prosthesis, it's important that physiotherapists work with the biomedical and materials engineers to ensure a successful recovery. While the engineers design the prosthesis to meet specific needs, physiotherapists must assess the patient's progress and functional abilities through a combination of exercises and therapies. Together, they can help him regain strength and mobility through customized therapies and prosthetic modifications. By working collaboratively, they ensure the prosthesis is comfortable, functional, and effective, and that the young man is able to achieve his rehabilitation goals with confidence, showing that with the right support, even the most devastating injuries can be overcome.